we are on geometry now for a little bit to get into the grade 12 2 theorems. This one is about the line parallel to one side of a triangle that divides the other two sides in the same proportion. That's what the theorem says. Whenever you've got this little situation with two parallel lines, you know that the top over the bottom is equal to the top over the bottom, or bottom over top, or whatever the scenario might be. But now this question started off by saying that AF is equal to FE, meaning AF, FE, and it doesn't even look like that on my sketch, and it could look worse than that as well, because remember, sketches aren't according to scale. So if AF is equal to FE, what is the ratio we're talking about there? It's 1 to 1. But if don't start with it and say that this is 1 to 1, and in any case, it's difficult here because it's the whole AF and the whole of FE. It is 1 to 1, but do not write 1, 1. If you did write it, you must write 1x and 1x, because you don't know what the actual length is. This actually is 2 centimeters and 3 centimeters and 1 centimeter and 4 centimeters. They gave that to you. But if you just have ratios, you don't say 1 and 4 and whatever. You call it 1x and 4x if you need to. Then also what they've given me is these two parallel lines. Now the parallel lines mean I've got that situation. So the triangle to identify there is what? Triangle with the parallel lines, A, C, F. So we say that in triangle ACF we have, so let's make this a green triangle, because color helps, with the green parallel lines. With the green parallel lines, what does that mean according to my theorem? If this is 2 and this is 3, then that should be 2 and 3. But ma'am, you just told me not to write that. Yes, we cannot write that. We must write x and 3x. Because it could just as well have been 4 centimeters and 6 centimeters, which is a 2 to 3 ratio. Or 20 to 30, or 200 to 300, or whatever. Times with 3 is 6, and times with 3 is 9. So 6 to 9 would still be 2 to 3. Okay, important. Now, going on with what we just started off with, if that thing was 2x and 3x, what does that make FE? How come? Because they are the same length. I don't know what the length is, but it's 5 something. So this 5 something is the same something, because of what they've given me. Now, they're wanting to prove that DG, in the big blue triangle, that DG is parallel to AC. Do you see the parallel lines? No, they're not parallel. But this is the converse theorem. And the converse works if you can see the actual proportions or the ratios. Now have a look, now we must look at that parallel line there. You can't look at 3 and 5. That's got nothing to do with that blue triangle. It's 8 and 2. You see it? From the top to the parallel want-to-be line is 8 and 2. But with this parallel line, this was 4 and 1. So what do you see? It's the same. So the converse is true, because 8 to 2 is the same as 4 to 1, meaning that those lines will be parallel. The sum is done. I have no marks because I haven't written anything. Where do I start? So in that triangle, the green one, we said that BG was parallel to CF or FC because it was given, which is normally not worth a mark. But that focuses you on it has to have parallel lines, so that I can say the following, that AG over GF would be the same as AB over BC, which was what? 2 to 3. And now even more than that, so that the person marking my test can see, I have called these 2x and 3x. It's not necessary here, but it's just to focus them on what's going on your sketch. And therefore, FE must be the same as AF, and that's now going to be equal to 5x, because they can follow what I've done here. 2x and 3x to get me the 5x. Are you with me? What's the reason? There's no reason. But then I go to the blue triangle, which is ACE. I'm trying to prove that the lines are parallel. So how am I going to do that? Because it's the first time we're writing it out. How am I going to prove that those two lines are parallel? You've got to tell me, look at 8 over 2. Look at 4 over 1. See it's the same. That's why it's parallel. I'm going to write it that way. So I'm going to say for instance, EG over GA is, read with me, meaning 4 over 1. Because here I don't have to have the x's. Even there I don't have to have the x's because it's a ratio. And then, and, what's the other one then? EG over GA, E, D over DC. And ED over DC was 4 over 1. Now, if you wanted to write 2 over 8, then this was 1 over 4. But they would still both be the same. So you can't flip them around. They've got to be in the same order. Then you say, listen, therefore, can you see that EG over GA is the same as ED over DC? It feels like a lot of writing, but this is the way to do it. Look at the one, look at the other one, see that they're the same. What's the reason? They're the same. Therefore, BC will be parallel to C. And my reason? Converse of line parallel to one side of a triangle. How many marks? So, you'd have to, oh, I've lost a mark. Line parallel to one side of a triangle. You have to, when you say that, why is it so that AG over those over each other are the same? Why is that so? Because of that theorem. There's a mark missing for me. And then there, knowing that it's 5x, because somewhere I've got to get to the 5 and the 8. Because the 8 wasn't given at all. Are you with me? You had to work it out. 2 and 3 and 5 and giving you the 8. And then looking at the two separately, seeing that it's the same, because that would be worth a mark. Not this, because this is the question. You never get a mark for what's been asked. And then also again for the answer. So that gives me like 6 marks. Approximately 5, 6, even 7 marks for such a sum. Right.
Yeah.